Welcome everybody. This is the recorded session we promised because we had some technical issues. Welcome to the GoodVision Webinars, our second webinar from the series. We're going to be looking at how to scale with extensive traffic data collection using visual analytics, and it's going to be more of a practical approach of taking your data and uploading your video recordings, and then a much deeper understanding of how to do that, and some interesting real-life case studies that we'll go into and show you. I'm just going to go to the next slide. So, as I said, this is going to be about how to scale with an extensive traffic data collection and using the visual analytics. So, I'll just introduce myself. My name's Chris. I'm the business manager, business development manager here in GoodVision, and I support some of you that might be on the call today with some projects all around the world. And I will be covering the practical tips, as I've mentioned, and looking at the GoodVision platform on how to use the platform in the scaling up of projects. I'm also joined today by Peter Hayduk, our Business Development Director, and he's going to share the aspects of handling a large-scale project of over 5,000 hours, and giving his experience and the support that we can provide and manage together with the GoodVision team. And he's also going to have some key advice and some advantages in the automation and the visual analytics platform, such as GoodVision. Just a few things about the webinar kind of etiquette and rules. The webinar will last approximately 30 to 40 minutes. All lines have been muted on entry. At any time during the presentation, you can submit your questions by using the toolbar that's either at the bottom or top of your screen, and you'll see a Q&A, and you can just simply click that to answer any, to send any or submit any questions during the presentation. Obviously, this is the recording, so if you have any questions, you can send them via email to us. We'll have our email contact address in the follow-up email, which will be sent to you within 48 hours of this recording, and then you'll be able to reply on any questions you might have. Additionally, we did have some questions during the live feed, so we can also add that to the follow-up. So please do, if you have any questions, let us know, send it to us, and we will answer them. So just going to the agenda, as I said, this is a more of a practical approach in today's webinar, focusing and understanding areas. So these are the areas we're going to be looking at. There's the visualization of the video, so your recordings, to the digitalization with GoodVision. And then also looking at the large-scale data collection that you have, and how that is kind of managed and used on the platform. And then Pete will go over a large-scale project case study with you, and then we'll have a Q&A at the end, and which we did have with some questions. And again, that will be either sent in the email you're now receiving, or if you have any questions additionally, please do get in contact with us. So as you may not know or know, that GoodVision is a SaaS-based platform that allows you to upload and digitalize captured video footage and extract all the data at once for your project needs. Data that is used in everyday jobs, such as surveyors, modelers, and traffic managers. So what you're seeing here are just a few of the key points of the platform, and as you can see, the first photo is your video footage, an example of some video footage that's been taken. Once you have that footage collected, either through third party yourself, you've collected it on a closed network or on a camera that's temporary, like GoPro or whatever, you will then upload this to the SaaS-based platform, which you can see in the middle photo here is the automation process of extracting and identifying classifications of vehicles and trajectories and things like this, the movements of the vehicles. That's all automated and done within an hour. And then the third photo along to the right is the platform itself, where users like the surveyors, modelers, and traffic managers would use to describe the scene and take the data that they need. And the few points here that we are out of the box, so there's no kind of deployment costs for the platform. There's no hardware that you need to add on to the platform. Our AI technology is proprietary AI, so we have a huge collection of footage and that we train our AI system with, and we have our own development team that are kind of always updating and developing the AI technology as we go and grow. And we also have edge real-time processing. So this is to decentralized data collection, and it's on site, so it's 24/7 monitoring, and it's completely privacy or data privacy protected because the device is working on its own in a location and sending data back to the platform at real time, so it can get processed. Just move on. So this here is the platform's ecosystem, or our ecosystem that we want to introduce. So in GoodVision, we believe that all parties involved in the traffic management process, this is cities, traffic surveyors, transport modelers, and traffic managers, can all benefit from having a standardized method and how traffic data is collected, stored, and analysed. So GoodVision is committed to create, as we like to say, a one-stop shop, or a single point of truth that all the traffic analytics tasks and the transportation that the transportation industry requires. Video insights is one of the first, complex SaaS platform where all parties involved in traffic projects can collaborate and perform their tasks or their daily work with data-related tasks in a fully interactive way. It's a comprehensive ecosystem of capabilities under one roof, and it's achievable by everyone globally. So it doesn't matter where you're working in the world, you can still collaborate together and use the platform for your data. Now, just to kind of single out this ecosystem, so we have traffic surveyors. So this is the point of the important part of the traffic data collection. So collecting all your recordings or your information that you're going to put onto the platform. And then the use of the traffic volume counting. So this is the most common and basic feature of capturing the traffic volumes on roads or junctions, roundabouts, and then the classification of the attendance of the objects or the classes that are either on the roads or junctions, so that the counts are multimodal that you can perform. And then we have the traffic modelers. So traffic modelers need to do, or you can do, their deep analysis of the traffic behavior. We can create a full digital version of the traffic behavior from the footage, which gives you the versatility and the visually allows you to see real trajectories in a digital rich environment. So that data collection is very rich with all the kind of scenarios or advanced movements that you would like to look at. And you can deeply analyze this and all physical aspects of the traffic. So it's giving you that aid to look more deeper at things, where you can't do when you just get if you get a video, you're seeing with your eyes the information, and you're just relying on the counts that you're getting into the system. This gives you the next step of actually being able to play with that real live information live. As you're talking about advanced movements, this is looking at the lane changes, red light running, jaywalkers, lane jumpers, and so on. And calculating parameters for traffic models, which is very important. So this is like saturation flows and detecting the ideal free flow conditions with this, and discovering areas which reduce speed, entering a traffic OD volume to models directly. So this platform, GoodVision platform, can help you transfer that information into other third-party systems like PTV, Vism, and things like that. And then to looking at the traffic managers, or the traffic managers area, this is an area now that is, at the minute, it's kind of faded because it's an area we're going into. This is an area we want to bring into the GoodVision platform to look at the traffic insights, real-time traffic events, and to help traffic managers look at real live incidents or something that's going on in real time, and be able to gather that data. So the traffic managers area is something that we're now developing and going into. This is a typical, when we look at large scale, the large scale processing cycle that we have with clients and we typically see. So this is the process starting with the kind of collection or continuous collection of footage on a fixed camera at a certain area or place that they're kind of looking at for a period of time. It could be multiple places with a temporary camera also. But you're looking at like maybe 300 sites, 400 sites, really depends on the size of the project that you're handling. And this is the brilliance of the platform of GoodVision, is where you can have as many locations as you need or required. And these locations can be recorded and simply uploaded onto the platform, and the automation process here, the automated video processing, will process all this footage that you have on locations and give you that data in 1 hour. So if you're loading up 72 hours of footage, it's going to give you that information in 1 hour. It's very powerful and very, very helpful for when you've got a large scale project, to give you that information quickly, because when you're doing this, without automation, it is a long process. Project in itself, in just collecting the data and having that process to get the raw data that you need from the recordings. And then, after it goes through the automation process, the video processing, it goes down ready for you. So the data filtering and visual analytics. So this is where the modelers or the surveyors will enter the platform, and they will then start to extract and make the movements, or do the scenarios for deep analysis on what exactly is happening on that scene, and how to filter that data to extract the information. And then once that information is extracted or filtered, should we say, it goes to the output. So the outputs, the exports, this is the reports, this is your saturation flow report, this is your OD matrix, this is your vehicle list, this is your gap time files and everything. And all this is in Excel. And also can be the platform can be connected. We have an API, or the platform's API based for GoodVision, so we can then connect to other third-party systems that are then using this output of the data that we filtered to do your modeling, or to go into an archive like C2 Cloud that most government agencies use to store collectively their output data, so people can extract that. So this is the kind of cycle. And then again, it will go back, if it's a large scale, to more recordings, because you're going over a certain period of time. You can stop recording in a certain area and re-record, as long as it's the same scene, the same section of road that you're recording. or you're just adding from the permanent camera extra recordings. You can keep doing this cycle, and your data set will grow, and the analytics of that data will be even bigger, and you can have that comparison. So this is the processing today. As I've mentioned, this is the cycle that we've just gone through. And how can we adjust our projects to be effectively automated, to avoid manual time-consuming areas, or removing that burden. And this is what GoodVision, the GoodVision platform, is looking to do, is to remove that burden of the collection kind of process of the processing of that collected data, because of course you've got to take the recordings, or if you've got a network of cameras that's there to take the recordings, that's perfect. It's removing the next process, or the middle process, of where someone has to sit there in front of your camera and take this information and give it to you in some kind of data form. So normal process of collecting this itself is a lot of manual. It's unnecessary, and it's a very old thing. Some people are still doing tallies for classifications. Well, I mean, in this day and age, we have the technology, and there's cameras more or less everywhere that can simply do this recording, and you can put it onto the platform in a couple of minutes. It can be uploaded, and then once it's uploaded, within an hour, you have that information. It's done. It's quick. There's no other person involved in this. It's all processed. And then also in the environment of GDPR. So when you have this data and you have to send it off to someone, you've got to make sure that they're GDPR compliant. And this is another area that's very difficult for people, or it makes the job more tougher. The GoodVision platform, or GoodVision ourselves, we are fully GDPR compliant. We have it's all automated, and no one is looking at your information apart from yourself that uploads onto the system. And once that's uploaded, the system is processing your video footage. The video footage is then deleted, and the data is stored, and that is what you'll use, what we use, so you can do your simulations and everything as well on the actual snapshots that you might see here on the right hand side. Sorry. This is an example of the platform in use, and these snapshots are kind of downgraded to blur out people's faces, license plates. So this is how we comply with GDPR, as well as not holding any kind of video footage or any data like that. It's deleted. And this is the tomorrow process, or that you can start straight away on a large scale project and start uploading your footage instantly. So we just, I'm going now into the areas of, we've talked about the recording and the ecosystem and who it covers. Now we're looking at the recording feasibility. So these are the parameters that you will follow, or need to follow, to get the results that you want from the system. And of course, every system or platform has a limitation, as we do, but we have simplified it as much as possible to make this as easy and as not cumbersome to handle and deal with. And these are the three areas that you really have to look at, or just keep in mind when we talk about the resolution. So the equation here is simple: crap in, crap out. Sorry for the language. The more the image data, or the pixels you provide to the system, the better the better the system can recognize the objects in this. So GoodVision Video Insights is trained to deliver the best accuracy on 1080p, 1280p. And then we go down to 1280 pixels times 720 pixels, and then 1920 pixels to 1080 pixels. So this is the full HD resolution. So you're looking at as I mentioned, cameras with the resolution of 180p to 720p pixelations is the parameters that you would need to use. Of course, the higher the better. I wouldn't go, or you shouldn't go below 720 pixels. And then when we talk about, obviously, not only the resolution, but the object clarity. So generally, GoodVision can handle low resolution all the way down to VAG quality. VGA quality. However, low resolution resolutions can go hand in hand with low quality. So the optics and the low bit rate causing objects, the contours of objects not to be so crisp. And that, you know, if you've got blurry footage, which I'll show you in a minute, it can lower the detection, and it's not ideal. So the better the clarity of the object, and this is the pixels on the actual screen, is in HD. You know, the pixels are very kind of condensed. We will be able to pick up things a lot better and a lot clearer. And then we have here is the frames per second. So frames per second is the smooth movement of the vehicles. Sometimes you've probably seen videos where things are jolting, or, you know, a video of cars that are moving, and it's like kind of, you know, like a slow-mo process. That is what is the frames per second. So the frames per second, ideally, the GoodVision Video Insights, which works well on most scenarios, is best between the frames per second of 30 frames per second to 10 FPS. So that's 30 FPS and 10 FPS, and a minimum for 10. You know, bigger the better. However, the SPS bigger than 30 seconds, you do not have to have any visibility impact in tracking all the quality. So, you know, you don't need to go higher than the 30 FPS, but you can't go lower, or shouldn't go lower than 10 FPS. And then the camera angle. So this is the angle, the visibility of allowing the system to track. So the camera tilt doesn't affect the detection ability of the platform of GoodVision, because it's trained and it's versatile in various conditions. You can just tilt the camera, you know, from horizontal up to straight down bird's eye view, you know, if needed. But it's just keeping in mind the horizon with the sunrise or sunset. If your camera's facing the sun when it rises, or when it's setting, and also thinking about objects that will be crossing. And what I'm going to do is I will show you examples of you know, do's and don'ts, so we can visually see and understand what we mean by these things of resolution, the clarity, and so on. So this is not ideal footage. This is the clarity that I'm talking about with the resolution. So it's a bit fuzzy, as you can see, but still, as the GoodVision platform is still classing and identifying the objects within this scene, it is still possible. Of course, the better the clarity or the pixels of the footage, the easier and the system will pick up the things on the scene. And as you can see here, it's classifying the vehicles as it's going, and you see the lines that are being drawn. These are the trajectories that you will see on your analytics screen, showing you the movements of these vehicles. So this is why it's giving you this data, quite visual, and you can see that. Obviously, you don't get the video on the platform. You'll see this in a raw kind of format of snapshots of the trajectories that you can filter out in the different classifications. And this is the ideal footage. So, you know, you're probably asking me, so what's needed again for these best results? As I've mentioned, and we'll go through these kind of one by one. And GoodVision Video Insights provides, you know, a greater than 95% accuracy of collected traffic data when you've got footage like this. Our processing supports all types of vehicles, bicycles, pedestrians. They all can be on a scene together. It makes no difference. All you have to do is achieve it and provide this quality input. And I'll go through these little areas just to show you what we mean by that, and just to give you the setting up especially when you're on a large scale project. You need to get the setup correct, because at that point, when you start taking all this recording and mass hours, it's very important to have that parameter. So then the information that you're receiving is smooth, simple, and doesn't take too much to analyze or help your modelers or the surveyors using the platform to see quality images so they can make the movements as well. So let's look at some examples. So this is the distance from objects. So objects that are around. You've got to keep in mind, if you've got a camera there on the left, which looks like it's for ANPR or something, so we can see license plate. This is not ideal. This is too close. You're not going to get any good data here. So on the right, obviously, you need to be covering an area that's not too great also, because you can't cover everything sometimes in one camera. There has to be some clarity here to see the objects in front of you. So that meaning, this is meaning that the vehicle length should be around, well, the picture, the clarity is 60 pixels on a 1280 pixel to 720 pixel scene. Some objects might be harder to detect in some cases. This is the effect due to other factors. This is lens, blur, etc. But also make sure objects are not covering substantial portions. So more than 30%. So our platform can detect a vehicle or object, 30% of that it's an object if it's seen. If more than that is not seen, or you've only got 10 or 20%, the system cannot detect it. So this is a difficult thing that you have to be aware of other things and objects in the way. Here, this is looking at the camera height. So camera height affects only your visual experience, not the system detection ability. The problem is when the camera is positioned at too low, causing objects in front covering the object in the back, which is not detected, not tracked, not collected. It's really simple to fix this issue and achieve great results. If the camera has a standard 2.8 lens equipped, place it between 5 to 35 meters above the ground, depending on the broad space that you want to cover, and which traffic attendants and the traffic attendants you want to monitor. So e.g. pedestrians, you have to think of what object you're going to capture, and it's different with pedestrians, but with vehicles you've just got to think that what is the best view to capture all the movements of these vehicles. And as you can see on the right, this is usually over a bridge or one of the kind of signs that will be over a motorway or road or lamppost, or if you have a fixed camera already there, these are the views you usually get. The one on the left is not so ideal. It's too low, so there's a car just going behind the red truck, and that's of course, if that stays behind the truck, you're not going to see it. Even if that was a manual counter there in the same position, they could miss that, could be behind the truck as it goes past, and you don't see it. So you have to think about this with the camera height. Here's the camera tilts. So again, this is also a height thing, so it's too low. You have to have the tilt down, so you kind of not occupying too much of the horizon within the view. So here on the right, okay. On the left, bad. It's too much there on the tilt. Again, this is the awareness, as I mentioned, with obstacles or the things that are obstructing the view. So if you've got huge objects in front of you or in front of the scene that you want to record, it's going to break your trajectories. It's not going to be ideal. This is covering the objects, covering objects going past that, probably 100%. So it will break the trajectory and pick it up after. And that's not ideal, because then you've got like multiple trajectories. This is perfect. You can have objects here that you see that are in the road, but they're small. So, it's less than 30%. It's covering the object, and it's perfect. You can see the vehicle through these objects, and it will still give you the trajectories because the algorithms in the system is connecting these together. And the lens quality, so or distortion. So you have to look at poor, the equipment or the camera you have. The poor lens, is it dirty? Is it scratched, smudged? It causes blurs to the images, removes object contours, or deforms it. So you do have to have a looked after camera that is usable. Raindrops as well, so sometimes you can get the raindrops on the lens. This is to do with the tilt, and some cameras have these little covers over the camera, so if it's raining and snowing, whatever, it's not going onto the lens, so tilting down also helps prevent that. And then the barrel distortion, so it deforms the objects, bends them, causes them to look nothing like the system's trained for. So that's something also to remember. And also light, as we mentioned, from the sun or from the street lights and things like this. You can't have light directly going into the camera. It's going to reduce the visibility and then reduce the detection. So ideally, you need to either face the cameras away from the sun or from light, or if it's facing the sun, it's at an angle where it's not going to get that glare into the lens. Here's the so lighting. We have the scene, or the scene lighting plays important role in video analytics as well. However, GoodVision Video Insights is trained to recognize even objects in the dark. The only condition is that objects must be at least a little bit illuminated and visible in the image with the naked eye. So as you can see here in the dark, we have the backlit areas of the other cars lighting up that vehicle, and the system can recognize that. If you have a pitch black area like this, we can't detect pedestrians or anything like that. There has to be some backlighting or a very well lit street so we can detect the movements of the objects. Here's the shutter speed. So shutter speed, this is very important. As you can see, if the camera shutter speed affects the clarity of the moving objects, the contours, especially in low light conditions and close to the camera. So some cameras switch to long shutter speeds in order to keep the same overall brightness on the scene during night. Try to avoid this and rather preserve the clarity of the object. GoodVision Video Insights is trying to recognize objects in the dark, but if objects are too smudgy or completely, lack a contour, it's super hard to detect them. And if you do all that, as you can see, it's actually easy to prepare the suitable footage in GoodVision. All of this, described conditions are, reasonable. They're kind of really no-brainers, because you wouldn't really kind of do anything other than what I've just mentioned. And if you get it right, this is the quality that you will get. These are the results that you can see here. The tracking is picking up all the vehicles and identifying them in the correct manner, and this is the result that you will get. Just moving on here into the ways of uploading and of your footage on a large scale. So large scale, you might want to have live streaming, which we have. So we have our platform is API based, so you can connect it to other platforms that might be doing recording for you, and that recording can then feed into the platform. And as you said, we have live streaming, so if you've got a closed network of cameras, that can be connected and collect your data on a large scale project very, very easily. And you can schedule that, automate it, you can forget about it, and you will just get the data onto your platform and you'll have that information. So when we look here then at standard, and there's drone processing. So you can have standard, this is just your your normal kind of standard processing for drones, which is like up to 50 meters. And if you go higher than 50 meters with drones, then usually modelers are using that when they want to look at whole intersection or multiple islands. You can go up to a height of 250, or between 50 and 250 is the high def processing. And standard processing, you can use a drone up to 50 meters and process it on the platform, and it's perfect. Then we have time-lapse processing. The GoodVision platform is capable of processing time-lapse. You just have to tick a box if your video is, time-lapsed, because it's compressed. A lot of people use this to save space on footage, because you're collecting quite a lot. We have a solution for that also, so you don't have to use time-lapse processing. It's not ideal, but we do handle it. I would say the best is just normal standard recording and not time-lapse processing. And then also very important is the stitching of multiple days or the videos together. You'll probably, on a large scale project, you'll have hundreds of files and you're like, man, I've got to upload these files one by one. No, you don't. So as long as it's on the same scene, you can select all your files for that one camera, simply upload it, multiple upload of all your files to the platform, and the platform will stitch all these video footage, all the footage in these folders together. As long as it's in consecutive, days, and it's the same camera, it will stitch all this information together and present on the platform these days in the time bar, time graph. So you don't have to worry about that in kind of putting them in, uploading them one by one in order. You can just select the whole lot for the same camera, and it will stitch that all together for you. And coming soon, we have the GoodVision Vault, or Vault at the minute. This is going to be a cloud-based video storage platform where you can upload your footage for projects that you might be having. You're not too sure on the processing yet, but you just want to put your video footage in the system, and you can upload that. Once it's uploaded, you can easily transfer the footage that you've taken and the cameras that you're looking at and upload it to the platform simply. And the beauty of this is that once you set that and once you've done it, because it's on the cloud and it's processing, it's going to the platform, you can close your laptop and leave it to process all these large scale hours onto the platform without worrying or affecting your PC once it's on the actual cloud and going to the platform. So that's coming soon. So please do look out for that. And then here, this is a kind of some footage to show you the actual filtering process of the platform. So this is giving you an idea of what you'll be seeing when you log on, and the movements. So you can see here the trajectories and the movements that can be made. And you can see the bar at the bottom is the time guide, and you can do the scenarios. So here, there's multiple scenarios. So this is the filtering process. So you can do stay events, you can do object stop events with zones, travel time events, and speed events. So this is all done from that side there. So going in again to the filtering and the quality of that. Here, you can see is the data processing of the artificial intelligence, and then you're filtering your information simply with advanced movements and the events. Now, once you've done your zone, so say you've got this large-scale project and it's for a 12 months period. Once you've set that scene with the described scene of your lines, your count gates, your zones, and you've marked it all, you don't need to do anything else. All you need to do is add the footage, or keep adding the footage to the scene, and your results or the widgets on the platform and the analysis will automatically update and change. And then within that, you can make the any kind of filtering or changes you want on the fly. And it's not costing you anything. You just change the movements, and you will get the results. And then after this, you get the output. So this is the reports that I was mentioning. This is the OD matrix. This is the saturation flows. This is all done within, minutes, sent to your email address or sent to multiple people for further, data processing, because it doesn't just stop with the output. The output can then, what you have from the filtering can be moved, as I mentioned, into third-party platforms like PTV, and you can use that on your simulations. And we're also looking to physically move the information directly into, as I mentioned, PTV Visimsay, to give you a base scenario. So you will have a complete simulation in your system as a baseline, and then you can start to manipulate and change that to the situation or the scenario that you're looking to achieve or to model. This is kind of a holy grail that I understand is needed within the industry. And this is just showing you the more in depth of the reports that I've gone through. So this data visualization, the widgets, which are the graphs, the volumes, the heat maps, the trajectories, and then the reports, as I said, with the TMC reports, vehicle lists, and the saturation flow. So this shows you the simple flow of getting all this data. But with the most important thing is how quickly you can get that, because it's processed within 1 hour. And once you've marked up the scene, these things are instant. You're getting your widget straight away. You can print off your report straight away. So you can handle large scale products with ease. There is no kind of lagging. There's no third party involved in getting this information for you. It's there in front of you. You can change it. You can move the parameters around to suit your project, because projects are always changing, especially with large scale projects. They change, and they get more kind of complicated, or things pop up. And this is the perfect platform to use to help with that. Now, just before I move on, I'm just going to introduce you to Pete. So Pete's our Global Business Development Director. He's going to go over with you a case study of a live project that he's involved with, and give his experience on how that you can use the platform as well on a large-scale project. So I'll just hand this over to Pete.
Hello, everyone. Chris, thank you for the words. I'm here to tell you a few words about how it looks like to do the large-scale project with GoodVision, because I'm receiving that question from our partners a lot. And so first, what does it mean, the large-scale project? Because this is the project which requires more than just daily use of a GoodVision. It typically requires over 5,000, even more hours of footage to be processed in a typically 50 and more sites, or in multiple cities. And it's being recorded for a time that is almost half a year or even several months. And well, let's talk about the difference, because obviously the question comes from let's say in confidence, because we are fully automated traffic analytical tool, and of course we are a software, but there is much more, because many of our partners in the beginning, they were scared. Okay, but you are just a tool, so I will start using you in our project, and what if something goes wrong? We always say it's not like that. It's just this is a tool, but it's wrapped with the several services that we really take care about, and we really ensure that our partners are getting the results without not any complication connected, that they will just start using the tool and they will not getting the results. Well, if you take a look on the old way how you collected your data in large scales, because what I've heard that many of our partners, they used to use external companies for accounting, which as a solution, it's not really effective, because you can imagine that you have to process all the documentation to every video that you record. You have to transfer the large amount of data to the external company. I'm not talking about the GDPR rules here, which is another story. And then you will wait for 7, 8, maybe 10 days until the results are delivered. And if something goes wrong, you need to let your videos recount it again, and that takes time as well. So this is something that causes ineffectivity and a lot of complication, even from organizational perspective. And this is something that we can fix, because we can process the large amounts of footage within just 1 hour. And then it's up to you to do your analytics. We can help you with that. And of course, this is something that even if you get your results or not on the expected level of accuracy, it typically requires just a bit of the troubleshooting. You can get back to your footage and get your results again on the satisfying level of accuracy. And also the definition of the large scale projects, it requires a more. So we are talking a lot with our partners about the specific requirements about those projects. Okay, so, but I believe that it would be much better to go to the real example, because just recently, around 7 months ago, we launched one of our large-scale processings with one of our partners. We are about to release this case study soon, so I'll definitely keep you updated. But I would like to talk about the process, how it went, what were the lessons learned that we found out from the utilization of such a technology. So I divided the story into 3 phases. The first one is the pre-project phase. This is basically how we got in touch with our partner. And the first thing was, okay, we knew that we are about to process around more to 15,000 of hours of footage on very specific area in Africa. And so therefore we had to do the tests on the partner's camera. Let's say the count cams were used in that example, which is obviously not the ideal camera. It's lower than 7, it provides a lower than 720 pixels footage, and this required a certain calibration. So the recognition was on satisfying level. And of course, we needed to provide enough of the technical training in here, because if you got a low resolution camera, you cannot just record the further areas. So you have to very carefully calibrate the camera angle to have a good recording and a good recognition as well. Additional thing was the confidence of the employees of the company, because they were about to use completely a new technology. So we really took care about the training and about the verification process itself, because we had to verify all the, let's say, all the typologies of the intersections, of the local intersections, and we have to provide enough of training considering the filtering placement and achieving the, so they can achieve the accuracy on the expected level. Well, the part of the verification process was, of course, the most important question, and that's this company usually used the services of external companies, because they were not able to count such a large amount of data in-house. And of course, the main worry was, okay, but if we upload such an amount of data to your system and we will not have enough of knowledge, how we can process that and ensure that we will get the satisfying results. Well, that was the point where we decided to support our partners with the services. So we decided to help them with initial placement of the filters. So that was the part where we decided to move forward, and we get to the realization phase, where if you imagine the project that takes 6 months and even more, it requires a lot of organization. So therefore, the first thing we done was that we set up the communication channels, because we are providing one of the most effective tools for traffic data analytics. So the communication had to be as well, so we don't slow our speed of processing and our effectivity. So the communication channels were set, and we allocated the project manager to this certain partner who was helping on a daily basis with the troubleshooting, with the quality checks, because we had to ensure that the results were on a good level. So we proactively, first, we placed the majority of the filters, and we proactively checked almost every video that's been uploaded, if the video is recorded well, and if our partner decided, when our partner decided to place his own filters, if he placed that well. Obviously, this is something that we do on the regular basis. In almost every video in our system, with our customer support, we are checking the style of the filter replacement, and we are trying to educate people using our platform as much as possible, so they are getting the results which are in the system. Well, the realization phase, of course, it took several months. So typically the videos were uploaded continuously, and some videos had to be reviewed again. And that was the part when another advantage played a very important role, because all the data were stored in the system, and our partners, when they needed some additional data or additional quality assurances, they just get back to the system, and they were able to export the data again or recalibrate the filters and basically continue. So there were almost no delays of the project caused by data analytics, because the analytics, to do it again, it took just several minutes, and it was all the time it's been stored in the system. So then, when we successfully processed all of these videos, of course, then there is the post-realization phase. That's the phase where you already have your filters placed, and you have your you have exported all the data, and you just upload and use this data for your microsimulations and creating your models. And this time to time, of course, it can happen that it reveals some suspicious data, which can you can just miss those anomalies. Of course, it happens, but once again, we store our data in our system for 12 months, and it can be even prolonged. So if you need to get back to those data, you just click on one button. It takes typically 3 to 4 minutes to recover, and you can export your data again. You can recalibrate your filters, and you can even increase the accuracy. Or if you realize that you need another data than just, for example, classified counts, you can just get back again and export your travel times, your time gaps, whatever you need additionally. So the analytics, this is very quick process with us. And as I said, the project went successful, and I really look forward to sharing some more details with you regarding to how to practically do the large scale processing with a GoodVision on a real example. Okay, so that was a quick talk about the large scale processing. Anyway, thank you for your attendance. As Chris mentioned, we are once again very sorry about the technical issues that occurred on our last webinar. We are about to release the next episode of our series in 14 days. I will definitely keep you updated, and I will share some more information about the topics. So once again, thank you for your attention. Have a great day, and I look forward to meeting you again.
Thank you, everybody.